Okay, today we're going to be working with volume again, but this time you're not going to know how many blocks there are in my figures. So we're going to learn how to solve for volume using that equation. So grab your journal, make sure to pause and solve when asked. Give it a try. Even if you get it wrong, at least you'll be learning. So here is our first one. You have to notice the base by the top because it doesn't really rotate, but that's okay. So here is our first figure. Remember, our equation, length times width, also known as base, bottom, butt, whatever you want to call it, times height, times layers. So, first thing we need to do is look at our base. So, this is a 4 by 2, 4 by 2. Yes, the parentheses matter, and your journal should be looking like mine. So, how many layers? How tall for that? 1, 2, 3, 4 by 4. So this is a 4 by 2 by 4. So now let's solve it, because I don't want to count all these blocks. There's a much more efficient way to figure out how many blocks is in this figure. So, with parentheses, that always means to do that math first. Whatever it is, you always do parentheses first. It's like it's screaming at you. Remember being on the playground trying to get your friend's attention from across the playground? You put your hands by your mouth so that your mouth is very loud. This is exactly what the parentheses are doing. They're screaming, do this math first. So we always do this one first. So 4 times 2 is 8. And then times that by 4. So 4s are double doubles. So 8 doubled is 16. 16 doubled is 32. So because we don't know how big these squares are, they could be feet, they could be miles, we don't know. Because it's not labeled in this figure, we're just going to call them units. And with volume, very important, you need to have a little floating 3 showing cubed, because it's a 3-dimensional figure. 1, 2, 3. This shows 3 dimensions. Remember in area, you had the length times the width, and you put a little floating 2 above the answer. So very similar to that, that's a 2D figure. So, like this is a 2D figure, because there's not 3 dimensions to it, it's just a length times a width. So area with a little 2, because it's a 2D figure, but now we're working with 3D figures, so that's why we have those 3 dimensions. So in here are 32 little squares. If you would like to pause and count them and prove that I'm right, go for it, but I'm going to go ahead and keep moving. All right. Here's another one. I want you to first find me the base, the bottom, the butt. What is it sitting on? What's the base dimensions? 1, 2, 3, 4 by 1, 2. So 4 by 2. Okay, so 4 by 2. How many layers of that? Just 2 by 2. So again, when we're solving, we do the parenthesis part first. So 4 times 2 is 8. Then times 2 for 16. Again, we don't know how big they are, so we're going to call it units cubed. Units cubed. Okay, your turn. Give me the whole equation. All right, so if I'm looking at the top part there, right, because this is what our base is going to look like. I see a 2 by 2, 2 by 2 for 2 layers. Now try and solve it. So remember, we're always doing the parenthesis part first. So 2 times 2 is 4 times 2 for 8 units cubed. So there are 8 squares. This one's a little bit easier to show. 8 squares to make up this entire figure. All right, how about a big one? Get me the equation for this one. All right, so I see 3 by 2. 3 by 2. Oops. And how many layers? 1, 2, 3, 4, 5, 6. Times 6. Now try and solve it. Okay, always doing the parenthesis part first. So 3 times 2 is 6. Times 6. So a few different ways you could do the 6s. 6s are 5s plus 1 set. So 6 times 5 is 30 plus 6 more. 36 units cubed. Again, if you would like to count them and see if we're right, go for it. But that's a lot of counting, and I like efficient ways because I'm lazy. All right, try that one. So I've got 1, 2, 3, 4, 5, 6, 7, 8 by 2 by 2. Try solving that one. All right, 8 times 2 is 16. Times 2, 32 units cubed. All right, I think you're doing pretty good, so I'm gonna go ahead and take away the cube part, and I'm just gonna give you the figure. Get me an equation for this one. All right, so here is our base. It's labeled for us, 6 centimeters by 2 centimeters. So 6 by 2, and that is 6 centimeters tall. So by 6. So 6 times 2 is 12 times 6. I'm just going to work this one off to the side here. 6 times 2 is 12. You couldn't see that. So I'm going to do 12 times 6. So 6 times 2 is 12. 2. Carry the 1. 6 times 1 is 6, plus 1 more is 7. 72. This one we do know how big it is, so we're going to put centimeters cubed. All right, try a couple more here. I'm starting to run out of room. Get me an equation for that one. Okay, so 4 by 2. I think I'm just going to draw me a space up here. We'll just move this up there. Okay, here we go. So 4 by 2 by 2. Solve it. So 4 times 2 is 8 times 2 for 16 centimeters cubed. 16 centimeters cubed. All right. Give that one a shot. Give me an equation. Okay, so the base, right, 2 by 2. 2 by 2 by 1. This one only goes up 1 tall. So 2 times 2 is 4 times 1, 4 centimeters cubed. So why is this important? Why does it matter? Why do we need to know the equation for volume? Why can't you just count the boxes? And here I have an example of why. So first thing we're going to do is come up with an equation. We're going to solve it, and then I'm going to show you why it's important to know how to do volume, especially with figures like these. So here's your base. And your height. and your equation. So this is a 3 by 3. 1, 2, 3, 4, 5, 6. So 3 times 3 is 9. 9 times 6 is 54. We're going to have to call this units because we don't know how big those little cubes are. So 54 units cubed. The reason why knowing volume is important, right? So with these other ones, especially like this one, I could just count the squares and know the answer. I wouldn't need to know how to solve for volume. Same thing for something like this. I could count this side and then I could just times it by 2 because I'd know what that side is. Or I could just go around and actually count all the blocks. You cannot count all the blocks on this particular figure. Let me show you why. Hopefully. There's 1, 2, 3, 4 cubes on the inside of this figure that you would never see if you were counting the outside, right? If I counted and I counted and I counted 1, you run into the risk of counting these corner pieces twice because they're on both sides, but then you also miss the 4 on the inside. So thinking back to when we were boxing baseballs, right? You wouldn't want to just leave this space empty. That would be a really silly box. I'll show you what it would look like here. It's a lot of deconstructing though. Right? So if you're building a box of baseballs and you took those 4 out, now you have this weird space in the middle. Something's gonna fall, it's gonna break. So these 4 blocks really do matter. But if you're just counting the outside, you wouldn't ever see those 4, which is why we have volume, to figure out how much space, even the space that you can't see. So if I had 2 of these put together, then there'd be 8 blocks on the inside that you would never see. So today you're gonna practice some more with this, and tomorrow we're gonna take it up a notch. Good work today, and I'll see you tomorrow. Bye guys.